I want you to imagine just for a second that you are hundreds of feet deep underground in a commercial mine.
Oh, wow. Yeah, completely cut off from the world.
Right. Or maybe you're out on an offshore oil rig with just the ocean roaring around you. Or you're standing inside this massive echoing aircraft hangar.
Basically anywhere really extreme.
Exactly. And you are staring down at a highly complex, highly dangerous piece of industrial equipment that is, well, it's malfunctioning.
Which is pretty much the worst case scenario.
It is. You need assistance to fix it safely. So naturally, you pull out your device to consult your company's cutting-edge AI system. You wake the screen, look at the top corner, and you see it.
0 bars.
0 bars. No Wi-Fi, no cellular connection, just nothing.
Yeah, that is a terrifying feeling in that context.
It really is. And that's the core question for today. What happens when physical, potentially hazardous work has to continue, but the internet just stops?
Well, I mean, it's the ultimate modern nightmare scenario for industrial operations, really.
Because you're so used to having everything connected, right?
Exactly.
Yeah.
We've grown so accustomed to having the entirety of human knowledge, and now artificial intelligence constantly tethered to us via the cloud. But in those extreme environments you just described, the cloud is often just, a ghost.
And that tension right there is what we are unpacking in today's deep dive. We've got our hands on a really fascinating document.
It's definitely a compelling read.
Yeah, it's a draft, currently unreleased press release from a company called EON AI Ventures. It's dated July 16th, 2026.
Right.
And our mission today is to really pull this document apart and understand EON's proposed solution. It's a product vision they're calling Field IQ Edge.
Which points to a future where AI in these intense physical workspaces is going completely offline.
Completely. Which is wild to think about. The way I was wrapping my head around it, it's kind of like when you download a movie onto your tablet right before a long flight.
Oh, right. So you don't have to rely on the terrible airplane Wi-Fi.
Exactly. Except in this case, instead of downloading like a rom-com, these workers are downloading an entire highly intelligent digital twin of their specific industrial environment.
And putting it right into their pocket.
Yeah.
That framing gets at the core concept, but we have to remember the stakes here are infinitely higher than a movie buffering. I mean, we are talking about the safety of human lives and multi-million-dollar infrastructure.
Okay, let's unpack this because I want to play devil's advocate right out of the gate here.
Sure, go for it.
We hear constantly about how massive the cloud is, right? How many billions of parameters these AI models have.
And how they need those vast server farms just to function.
Right. So if cloud AI is so incredibly powerful and can process all that data, why do we need to force it onto a local device like a phone or a tablet at all?
Well,
isn't the whole point of the modern internet that the device is just a dumb window to the super smart cloud?
Normally, yes. I mean, if you need broad enterprise search or if you're running computationally heavy simulations for a global supply chain, the cloud is absolutely where you want to be.
Okay.
But the core problem this text highlights is that the cloud becomes a massive liability when fast, trusted guidance is quite literally a matter of life or death.
Right, because of the connection issue.
Exactly. Think about it this way. If you've ever tried to load a simple web page on, like, spotty hotel Wi-Fi, you know how frustrating a dropped connection is.
Oh, I know it too well.
Now, imagine that dropped connection happens while you're holding a blowtorch next to an aviation fuel line.
Yeah, a buffering wheel is not what I want to see in that moment.
Precisely. The document points out several vulnerabilities of relying on the cloud for physical work, but a few really stand out. Continuity, for one.
Workflows just shouldn't break when a network drops.
Right. And privacy and sovereignty-sensitive operational data shouldn't be leaving the site. Plus, there's resilience, reducing reliance on external APIs.
And I imagine cost is a factor, too.
Oh, definitely. Streaming continuous video to the cloud for inference is incredibly expensive. But the biggest vulnerability of all is latency.
Latency, meaning the delay in getting an answer.
Yeah. Imagine that oil rig scenario you mentioned. If a worker is about to turn a highly pressurized valve the wrong way, the AI system needs to recognize the danger through the device's camera and issue a stop command instantly.
Instantly. No delay at all.
Right. You cannot have a 2-second round-trip delay where the video frame is sent to a server in Virginia, processed, and the warning is sent back. That latency is the difference between a safe shift and a catastrophic blowout.
Wow. Which brings us to a quote from EON's founder and chairman, Dan Lajerskar, that really jumped out at me from the text.
The one about Wi-Fi.
Yeah. He says physical work cannot pause at the edge of a Wi-Fi signal. It's such a striking image.
It really perfectly encapsulates the problem.
But here's my pushback. By taking the AI offline, pulling it out of the cloud and cramming it onto a tablet, aren't we inherently making the AI dumber? I mean, we are constantly told that true reasoning in AI needs massive, uninterrupted computing power.
That is a very common assumption, yeah. But it misses the fundamental goal of industrial AI. It is not about raw, generalized intelligence. It is about absolute dependability.
Dependability.
Okay, a worker standing in front of a volatile chemical mixer doesn't need an AI that can write a sonnet in the style of Shakespeare.
Right?
Or, explain quantum physics. They need an AI that knows exactly what that specific mixer does, what the safety protocol is, and can deliver that information instantly without waiting for a remote server to make a decision.
I see. So we are trading general knowledge for hyper-specific reliability.
Exactly.
But since we aren't downloading the entire cloud, what exactly is going on to these devices? The document uses the term digital twin over and over again.
It's a key concept for them.
Can we translate that into plain English? What is this twin they're carrying around?
So when EON uses the term digital twin here, they literally mean a one-to-one virtual replica of the physical workspace. The broader architecture involved things they call Genesis, EON Universal, EON On Live, and Situation Room. Basically, every pipe, every wire, every maintenance manual, and every safety protocol of that specific oil rig or factory is mapped out in 3D data and interconnected.
Like a massively complex video game level of your actual workplace.
That's a really helpful way to visualize it, yeah. But the key is that Field IQ Edge, the offline product, does not try to swallow that entire system.
Because it wouldn't fit.
Right. It only takes a bounded, highly trusted portion of that twin. It's specifically tailored to the user's role, the exact set of assets they will be interacting with on that specific shift, and the mission they are trying to accomplish.
Okay, so the worker's device knows exactly who they are, where they are, and what they're looking at.
Exactly. And it lives right on their phone, tablet, smart glasses, or local edge computer.
The press release lists some specific capabilities for the Field IQ Edge role, like recognize identifying equipment or QR tags.
And Understand, which is resolving what the asset is through visual evidence.
Then there's Guide, which pulls up the standard operating procedures, the SOPs, and checklists.
And Capture, recording photos and voice notes locally.
Right. But the feature I really want to focus on is what they call Protect.
Ah, the safety mechanism. This is huge.
It seems like it. The text says the Protect capability will enforce deterministic prerequisites and stop conditions outside generative model weights.
Yeah, that's a mouthful.
That phrase, outside generative model weights, is incredibly dense. What is actually happening under the hood there?
This is perhaps the most crucial technical distinction in the entire document. When we talk about generative model weights, we are talking about the way large language models, like the popular chatbots we use every day, actually function.
Okay.
They are probabilistic. They predict the next most likely word in a sequence. They are essentially making highly educated guesses based on massive patterns of data.
Which is why they sometimes hallucinate or give you an answer that sounds super confident but is completely wrong.
Yes. Now imagine a worker asking a probabilistic AI, is it safe to cut this high voltage wire?
Oh, no.
Right. You absolutely do not want the AI guessing the answer based on internet probabilities.
Definitely not.
What EON is stating here is that the safety limits, the stop conditions, the hard rules of the job are explicitly separated from that generative guesswork.
Okay, so they're not guessing at all.
No. They are hard-coded, deterministic rules. It means if X is true, do Y. Never do Z under any circumstance. It is an AI system that has strict, unbendable boundaries built around its own reasoning. It knows its own limits.
It's not a chatbot trying to wing it on an oil rig.
Exactly.
It has actual guardrails. But this brings up a huge logistical question for me.
What's that?
Wait, you're telling me they can take a massive AI model, complex 3D spatial data, hard-coded safety gates, and massive operating manuals, chop it into pieces, and only put the relevant parts on a standard Android phone? How does the AI not just completely break when you sever it from its main knowledge base? And how do you do that without melting the phone's battery or taking up, terabytes of storage space?
You've hit on the exact engineering hurdle they are addressing here. EON uses a proprietary process they call work intelligence distillation.
Distillation, okay.
The text explicitly notes that the goal is not to squeeze the entire enterprise system into a small model. That would be impossible.
Right.
Instead, they select relevant assets and ground the guidance strictly in the digital twin. So it's not a generic response.
Yeah.
Then, they use techniques to compress the vision and speech components.
Compress them, like making the file smaller.
Yeah. Think of it like taking a massive high-resolution photograph and slightly lowering the megapixel count. The image still looks exactly the same to the human eye. You can still see all the details you need, but the file size is drastically smaller.
Oh, I see.
They do that to the AI's brain, trimming the mathematical precision of the neural network just enough so it fits on a phone without losing its core logic or reasoning capabilities. Then they compile those hard-coded safety gates and optimize the whole thing for the hardware.
Okay. And this is why the press release uses a very deliberate phrase. It says, Field IQ Edge is a package, not a chatbot.
Yes, they are selling a highly engineered, secure software container.
And it's worth noting how ownership works here, too. EON provides these reusable intelligence layers for aerospace, mining, healthcare, but the customer retains total ownership of their private data.
Absolutely. The maintenance history, the private procedures, that all stays with the company.
It's kind of like packing a survival kit for a highly specific mission-critical mountain climb.
Oh, I like that analogy.
You don't bring the entire inventory of a hardware store with you. You bring exactly the tools you need for that specific mountain, tested and validated for that specific terrain.
That is a phenomenal way to put it.
But with a crucial difference. This kit will literally refuse to open if you try to use the flare gun inside a highly flammable tent. It has physical safety gates built in.
You carry exactly what you need to survive and execute the mission, and the tools themselves prevent you from making a fatal error.
Okay, so our worker has their highly specialized, tightly governed survival kit packed into their tablet.
Yep, ready to go.
They are stepping out of Wi-Fi range and into the mine or the hangar. What does their day-to-day experience actually look like when they boot this up?
Well, EON outlines 5 levels of edge capability to show how this technology actually scales in practice during a worker shift.
What's level 1?
Level 1 is carry, that's just offline manuals and diagrams, replacing a giant 3-ring binder.
Okay, simple enough.
Then level 2 is C. A worker can hold their tablet's camera up to a complex array of pipes, and the device, entirely offline, recognizes exactly which pump is which.
It overlays the digital information onto the physical world.
Correct. Level 3 is Assist, which allows for offline bounded Q&A. The worker can ask the system questions bounded by that specific package.
Like, what's the torque spec for this bolt?
Exactly. Then level 4 is Guide. This is where it walks them through offline conditional workflows. It can use contextual augmented reality to show them exactly which bolt to turn, all while enforcing those hard-coded safety gates without a single bar of internet signal.
That's incredible. But wait, what about level 5?
Level 5 is Connect. That's connected fleet reasoning and global analytics.
Wait, let me stop you right there because I'm spotting a pretty major logical bottleneck here.
Okay.
The first 4 levels, carry, see, assist, and guide, are fully offline, which is great for the worker in the moment, but level 5 requires connection.
It does.
The document also talks about this EON Work Intelligence flywheel, where the system captures data in the field, passes it to assess IQ to measure performance, then to compound IQ to extract lessons, and finally updates the main digital twin.
That's the ecosystem, yes.
Doesn't this mean the system's ability to learn and improve completely stalls out the minute they lose signal? The AI can't get smarter if it's trapped in a disconnected phone deep underground.
You've zeroed in on a critical vulnerability of offline systems. And it's the exact reason why the final core capability of Field IQ Edge isn't just about doing the work, it's a function called synchronize.
Synchronize, meaning it reconnects later.
Yes. The system is designed as a closed loop. While the worker is offline, the edge device isn't just giving instructions. It is meticulously capturing what they call the real operational delta.
What does that mean in practice, the delta?
It means the device is quietly taking notes the whole time. It records the exact steps taken, the visual evidence of the completed work, voice notes from the worker, and any exceptions.
Oh, like if something didn't go according to plan.
Exactly. For example, if a valve was much harder to turn than the manual suggested, the worker logs that locally.
Ah, so it's gathering the on-the-ground reality.
Yes. And the moment that device crosses back into Wi-Fi or cellular range, say, when the worker heads back to the break room or the main office, the synchronize function immediately beams that governed, verified field record back up to the cloud.
I see.
It passes to those analytics engines you mentioned to measure the outcomes, extract lessons, and update the master EON Digital Twin.
Okay.
So the learning is delayed by the duration of the shift, but the entire enterprise instantly gets smarter the second that connection is restored.
Okay, that makes sense. It's asynchronous learning.
Precisely.
But here is where my skepticism kicks in again. Everything we've discussed, the deterministic safety gates, the distillation making it fit on a phone, the seamless syncs, it all sounds like incredible, flawless theory.
It sounds great on paper.
Right. But in high-stakes environments like refineries or hospitals, you can't just deploy untested theory and hope for the best. If I'm running a refinery, I need absolute proof.
Of course.
How is EON planning to prove this actually works in the real world?
Well, what's really telling is how EON plans to actually test this. They detail a proposed first pilot in the press release.
Okay, what is it?
They are going out to an oil and gas facility for a 90-day reference pilot to prove the architecture before they move to broader commercial availability. But they are keeping the leash incredibly tight.
How narrow are we talking here?
Very narrow. They are limiting it to just one facility area, between 20 to 50 tagged assets.
Wow.
Only 2 or 3 equipment classes, just one inspection workflow, one maintenance workflow, and one single abnormal condition scenario.
That is tiny.
And the ultimate test of all of this is what they call a complete airplane mode acceptance test for the core mission.
I have to admit, that scope seems shockingly small to me. I mean, the press release boasts that EON is built on more than 25 years of immersive learning and digital twin development.
They have a long history, yeah.
For a company with that kind of pedigree, testing a system on just 20 to 50 assets seems, I don't know, tiny. Why not 1,000 assets? Why not a whole facility?
Because in the world of dangerous physical work, scale is entirely secondary to absolute certainty. That narrowness is the entire point of the pilot.
How so?
Proving absolute, deterministic safety and flawless offline performance on just one complex, abnormal scenario without an internet connection is exponentially more difficult and infinitely more valuable to an industrial client than building a generalized AI that works across 1,000 assets but only gets it right 95% of the time.
Because that 5% margin of error gets people hurt on an oil rig.
Exactly. Success for this pilot won't be measured by how many trivia facts the AI knows. It will be measured by offline response time, correct procedure retrieval, safe workflow completion, and the reliability of that synchronization when it reconnects.
So it's about depth, not breadth.
Yes. If they can prove it works perfectly in a hyper-focused, disconnected bubble, they can scale it. If it fails in the bubble, the entire concept collapses.
So let's take a step back and look at the whole picture. It feels like we're witnessing a major paradigm shift in how we think about the future of technology.
We really are.
For the last decade, the narrative has been that the future of AI is just massive cloud-based omnipotence. Bigger servers, more data, constant connection to a central brain.
Right.
But what EON is proposing with Field IQ Edge is the exact opposite.
It's the decentralization of intelligence.
Exactly. The future they are building is highly specialized, strictly bounded, completely offline mission packages, AI that travels securely in a worker's pocket to the most remote, disconnected, and dangerous workspaces on Earth.
It's a completely different approach.
It is, and whether you work in a hospital basement, a deep utility corridor, or honestly, even if you just occasionally lose cell service in a concrete elevator, this concept of localized, specialized AI is going to fundamentally reshape how we interact with technology in the physical world.
It is a profound evolution.
Yeah.
And, it leaves us with an interesting paradox to consider based on what's in the text.
Oh, what's that?
By taking the AI offline, by putting it into localized edge devices with these hard-coded deterministic safety rules, EON is effectively cutting the cord to the outside world.
Right.
On one hand, this brilliantly protects critical infrastructure from remote cyber attacks and network outages. An attacker can't hack a device that isn't connected to the internet.
That's a great point. Air-gapped.
Exactly.
Yeah.
But on the other hand, look at what we are doing. We are now placing the literal brains and the core safety protocols of our most dangerous facilities onto portable tablets and phones.
Devices that can be dropped or lost?
Right. Devices that are physically carried around by fallible human workers in chaotic environments. So are we securing the future of physical work or just moving the vulnerability from the cloud directly into the worker's hands?
Wow. It's an incredible trade-off. You solve the Wi-Fi problem, but you literally turn the worker's pocket into the most critical cybersecurity node on the rig.
Something to think about.
That is a wild reality to chew on. Well, thank you so much for joining us on this deep dive. And next time you look at your phone and see 0 bars, just remember, The intelligence might still be right there in your pocket, completely off the grid. Until next time.